Now let's see the expression of work when force is applied not in the same direction of displacement. What is the meaning of this? Carefully see. In the previous definition, we have seen that work is done on a body when force is applied on a body and body displaces in the direction of force. But here the body not displaces in the direction of force. Why? Because force is acting in this direction and displacement occur in this direction. It means that force and displacement are not in the same direction. So what is the formula of work done when force and displacement not occur in a same direction? That formula we have to derive. Okay. Now let's see how we will calculate the work done when force and displacement is not in the same direction. So in this case, force is applying in this direction and displacement occur in this direction. So force direction is this, displacement direction is this. So now what we will do, carefully listen. We have two choices according to the definition of work done, that is force occur in the direction of displacement. So what we can do, either we can take displacement in the direction of force or we can take force in the direction of displacement. So in this expression of work done, what we will do, we will take displacement in the direction of force. So if you will see, here we have three directions. If I make a right angle triangle here we have three directions, named it as A, B, C. So here we have AB direction, BC direction and AC direction. AC is the actual displacement covered by the block, but AB is a displacement covered by block in the direction of displacement. Okay, so here if you will carefully see, so here if you will see the block, so this direction is force direction and displacement covered by the block in the direction of force is this shadow. Okay, so this displacement now we will calculate. So here force is here. Now when we will make a diagram, so this angle is 90°. So this is the displacement which occurs in the direction of force. Okay, angle between the force and the displacement is theta. Now what we will do, we need, see, theta, in front of theta we have perpendicular, 90 in front of hypotenuse and rest is base. Here we will use trigonometric formulas, which is Pandit Badri Prasad Har Har Bole Sona Chandi Tole. This you have done in math or you will do in math. Now carefully see, here you need what? Here you need base. As x we have to calculate displacement in the direction of force and hypotenuse work as a displacement. So these two things we need. Okay, so we need base and hypotenuse. Base and hypotenuse covered with this c. C here is cos theta. So in triangle ABC, cos theta is base upon hypotenuse. Cos theta remains same. Base value we have x and displacement hypotenuse we have displacement. So x value we got by cross multiply as s cos theta. Now carefully see what is work done. Work done formula we have force and displacement occur in the direction of force. Force and displacement occur in the direction of force. So F is same. So x we got what? X value we have s cos theta. Okay. So here we got a formula, work done formula as W is equals to Fs cos theta. So this is the formula of work done when force and displacement are at some angle theta. So angle between force and displacement is theta. So work done formula we got Fs cos theta. So here s cos theta represent the component of displacement in the direction of force. This is displacement, but component of displacement in the direction of force is actually a s cos theta. Clear? So here if you will see, W is equals to Fs cos theta. So here work done is force and s cos theta represent here component of displacement in the direction of force. So this is the first expression and important expression for the numerical point of view when force and displacement not occur in the same direction. Now first thing we have done, we took displacement in the direction of force. Now next case we will see, here what we will do, we will take a force in the direction of displacement. In this case, we will make a formula of work done when force we will take in the direction. So how we will take force? So carefully see, this angle is theta. So this is the force which I am taking in the direction of displacement. I am not taking the component of displacement now. I am taking component of force in the direction of displacement. Now this force and this displacement occur in same direction. F dash I am taking here. So here this is a perpendicular 90 degree. So this triangle again ABC. So these angles are vertically opposite. So this angle is also theta. So again theta, in front of theta we have a perpendicular, 90 in front of we have a hypotenuse, and this is base. Okay. Now we need F dash we have to calculate, and F we have act as a hypotenuse. Again Pandit Badri Prasad har har bole, sona chandi tole. Now carefully see, base we required, hypotenuse we have. Again we will choose which formula? Cos theta. Cos theta is base upon hypotenuse. Base act as a, in this triangle base act as a F dash, which is the component of force in the direction of displacement, and hypotenuse act as a force. So F dash we got as F cos theta. So what is the formula of work done? Work done formula we have force which is in the direction of displacement into displacement. Here we are taking this displacement and force we are taking in the direction of displacement. F dash value we have F cos theta into S. So this is the formula we got similar to the previous formula, that is Fs cos theta, or you can also write W as F cos theta S, which is already written. Okay, now carefully see, here work done is component of force in the direction of displacement, and this is a displacement. So if you will see the formula, so here we have W is equals to F cos theta S. So here work done is component of force in the direction of displacement into displacement. So in this two way you will derive a formula when force and displacement occur at some angle. But here good thing is that formula is same. In previous case we got Fs cos theta, in this case we got F cos theta. So magnitude wise they are same and direction wise also same. So here you will get a formula. This expression of work done is very important.